sir.
Hi. How's it going?
Pretty good.
All right, so before we get started, I set aside some parts onto the desk that you were working on today. And you should be able to assemble everything with relative ease. Like I found some new spacers, and those new spacers should do the trick.
Oh, okay. Thank you so much.
No problem. Thank you. I appreciate you taking the time to assemble this turret kit. I'm trying out a new camera angle because we are recording, and so we will be posting this to our YouTube channel, and hopefully we'll be distributing this among partner teams with the Covalence crew. So it'll be nice to share all the knowledge that comes out of all the students designing stuff.
Oh, that's pretty cool.
Yeah. So we're going to take a look at a couple of different designs. Number one is going to be the gearbox because I've actually discovered some ways to upgrade it. So we're going to upgrade it, and then we're going to print a new one for you to assemble for real this time, because the one that you had to drill out, you shouldn't have to drill it out. So we're just going to make the holes bigger and then 3D print it again.
Okay. Sounds cool. Sounds pretty good.
Cool. Do you know of anyone who's going to be joining us?
I just called Astrid. She's joining.
Okay, awesome. We will wait a moment or two before we get started.
Okay.
So from here on in, I will be speaking to camera, just to let you know. And speaking as if we are viewing it on YouTube in the future, because that's the best way to record stuff. So to those of you watching in the future on YouTube, hello, welcome. Glad you can make it. I'm Mr. Steele. I run the robotics group for Team 9062, Critical Circuits out of Columbia International College. And this is our CAD training seminar. This is the second time that we've run a full seminar series with like a tutorial section. This does not supplement the stuff that OnShape has produced. However, this is what I find to be a pretty good intro for students who are just starting out with CAD. OnShape is super easy. It's cloud-based. It saves in the cloud automatically. SolidWorks is more accurate. Fusion 360 is also a good competitor, but I happen to prefer OnShape because it's really user-friendly. Let's tab over here to here. And here's what I'm working on right now. Giselle, can you see?
Yes.
Okay, so this is the 2D sketch drawing for all of the important parts of a output plate. So the thicker of the two yellow plates, this is the custom one that I designed for the turret. And I've just gone in and I've changed these two values here and here for the inside hole. This used to be 0.188 to match the other two, and they are good as sort of a clearance hole for a clearance hole for a number 8 screw, but we need to fit a number 10 bolt. I'm just gonna exit out of that and see how that rebuilds. Okay, that rebuilds pretty well. Now we can go in and edit how thick it's going to be because it ended up being a little bit too thick. Sure, we'll go with 0.250. And before we keep going, we need to find a bearing. Oh well, I'll find a bearing eventually. Pretty sure off by heart that this is the right depth for it. We can print it again. It doesn't need to be this thick, really. Welcome, Astrid. Glad you can make it. All right, Astrid, to catch you up, we are editing the size and thickness of certain features on this plate that Giselle was working on earlier today. This is a gearbox plate, and it's fairly complicated only because the motor that we're trying to mount to is a really annoying size and shape. We've had to try and put these this triangular bolt circle. It's not even really a bolt circle. It's just 3 random holes that line up this motor. So we have to determine the location, which we've finally got down. And now we are modifying this plate here as the output shaft. So I think that should be all right. Extrude 2 and extrude 3, they're just this little hole here so that we can embed the bearing into it. I think that should run just fine. So I'm going to close this document for now, and we can interpret it and print it later. So something that we are going to start on is a version of a hex spacer. And the hex spacers are designed to go over 0.5 inch hex. And there's also, this one in particular is supposed to fit inside of a 5/8 or 0.625 inch hole inside of a IGUS slide bearing. So we're going to try and modify this so that it slides in, but then will not move left or right. We're going to play around with tolerancing on this. So I think I've got one. Okay, got one. I'm going to rename it. Maybe I'll just make a new one. Yeah, okay. Second thought, I'll just make a new one. So can I get both of you to create a new document by clicking this button and then this button? You can rename it whatever you want, but I'm going to be renaming it something that's accurate to what we're going to be building. So to describe this, we will probably be calling it a 1/2 hex IGUS bushing, because that describes what it is. A bushing is a thing that moves but does not have ball bearings on the inside, so it's not a bearing. It's just something to help with the rotation of something. So it's an IGUS bushing that we are mounting to, so we are going to be using 1/2 inch hex IGUS bushing adapter. Owned by me, document labels. We're not going to worry about document labels. Okay, so we should be able to find our way to this plane of existence. There's 3 planes of existence, just like we have in real life. So we've got the horizontal dimensions here, and then we've got a vertical dimension here. And between the 3, you get a fully defined 3-dimensional part. Astrid, are you with us so far?
Yeah, everything's good.
Awesome. Okay. So we're going to act like we're going to 3D print this, because we are in fact going to 3D print this. All the stuff that I've got in this little sharing bucket are 3D printed. So we go from the simplest of shapes, which is a hexagon and a circle, all the way up to some really complicated geometry there. And this piece, which was designed in May, which is a lot of compound angles, a lot of really, really precise stuff. So we're going to play around with this so that it fits within a bushing that mounts to one of these. In order to 3D print stuff.
I need to sign in this. Sorry.
Oh, no worries. Martin, you're wondering how to sign into this?
Yes, or if I see request a trial and sign in and create a student account.
Student account's the one you're going to want to sign up for.
Oh,
Great
okay.
question. So you want to sign up for a student account, use your email, create a login, stuff like that. And then near the end of today's lesson, I can go back and start from scratch again. This is what it looks like when you open up a new document, Martin. So this is the new document, three-dimensional planes of existence. We have the top plane, the front plane, and the right plane. And they're labeled by where you are when you're looking at it. So when you're looking at the top view like this, you are on top of the part. I am looking at a part like this if I am looking at the top view. If I'm looking at it from the front, then I'm looking at it like this. And the right view is if I'm looking at it like this.
Yeah, got it.
Welcome, Mark. Nice to see you again, Mark. Okay, so the reason that I selected the top plane is because anytime you want to 3D print stuff, and it's a simple part and you know you're going to 3D print it, it's just easier on the translator software like Cura or some other Ultimaker product. You need to translate it to something that can print in horizontal layers. So if you start looking down, you build it up in horizontal layers, kind of like a 3D printer. It makes it super easy for the 3D printer to understand what you're building and super easy for the 3D printer to do its stuff. All right, thanks, Mark. Glad to hear it. So starting from the top view, we are going to enter in a new sketch. And we want to select a sketch plane, it's telling us. And the only sketch plane visible to us is the top view. So we're going to select the top view. And it says, great, okay, you're going to do a drawing on this horizontal piece of paper. And when you're done this drawing on the horizontal piece of paper, you can then stretch the drawing up into three-dimensional space. But for now, it's just a three-dimensional piece of paper. Sorry, two-dimensional piece of paper. Three-dimensional pieces of paper, that's just called a tree. Top view, we want to start with probably a hexagon, which is over here, an inscribed polygon. And those two words might be a little bit confusing. An inscribed polygon refers to a polygon, which is a multiple-sided shape that is enclosed, containing 3 or more lines. Inscribed means you draw a circle, and then that circle defines the midpoint of each line. A circumscribed polygon is the opposite, where you draw the circle bigger than the object you're trying to make, and then the points, the vertices of that polygon are filled in along that circle. We don't want to do that. When we measure a hexagon, we measure the short, flat sides rather than the sharp points. So we're going to do an inscribed polygon. And we're going to click on the origin point, which is this little orange dot that shows up when we hover over it. This makes it super easy when we go to 3D print. It will just automatically put it directly in the center of our 3D print surface. So I clicked it, and now I'm dragging my mouse around without holding down anything. And it looks like a Doctor Strange sling ring. And that's because it's asking us where we want the outside point to be placed. Now, it doesn't really matter with what we're doing. However, if you've already drawn something, this part is important. Seeing as this is the first thing that we're laying down here, it doesn't really matter. So I'm just going to click along the horizontal plane, somewhere like that. And now, without moving your mouse, it goes, whoa, whoa, before I continue, how many sides am I making again? And you can drag your mouse around without hovering, and it will change the amount of sides you have. So you can go from 3 all the way up to like 1,000, but we just want 6. So when you hover around it until it says 6, and then you left click, it then goes, great. We have 6-sided object and it's here. Where is here? 0, 0, 0. How big is here? We don't know. So we can deselect the tool before we continue. And before I continue, I should ask, is everyone on the same page here? Aside from Martin, who's making a new account, have we created the hexagon along with me?
Yes.
Awesome. Okay, so moving forward, we have a dimension tool, and a dimension is a label that we place on objects to tell people how to make it or tell people how big it is. So if I were to try and define this part here, which we have done because it exists in a 3D printed form, meaning somebody designed this at some point, there is a definitive size to all of these holes on it. There's a definitive size to the outer edge here, and a definitive size hole to hole. All of these are labels that were likely placed in this software to then be able to stretch up a model in this plane. So it was designed like this, and then it was stretched outward and then became this three-dimensional object. So we want to put as many labels on stuff as possible, as long as the labels do not over-define the object. We need the right number of labels. So by clicking the dimension tool, or what I've been calling the labeling tool, we can then hover over this inscribed circle. This circle is actually the dimension along the horizontal, or the midpoints, between the hexagon. So this allows us to define the thickness of the hexagon without defining anything else. And it defines it in all three sections of the normal hexagon. So I've clicked the perimeter, and now I can place a label anywhere I want. I like to place all my labels outside the part, and I don't like the lines to cross each other. It looks a little annoying if it's like this, so we're gonna put it like here. And now that we've placed the label, we can now edit the label. The label, or the dimension, will automatically resize the object to exactly what size we type in. We can type in IN for inches, MM for millimeters, M for meters, CM for centimeters, and so on. It accepts math, it accepts decimals, and it accepts fractions. So as long as we can enter in any of those with enough detail, it can understand it. So I'll show you guys in an example. We want a 1/2 inch hex. So if I type in 1/2 and my units are in inches and then hit enter, it automatically resized it from 3 inches to 0.5 inches. I'm just going to zoom in again. Zooming is going to be a little difficult for those of you joining us on laptops. You have to select everything on your screen and then right click and then zoom to selection. As far as I'm aware, that is the easiest way to zoom in without altering which way that you're facing. You can change how you're facing using this menu up in the top right corner. So I feel like now we should probably talk about tolerances a little bit. When you design something to be 3D printed, the 3D printer goes to the closest it can, but there are some limitations. It can't print to the nearest micron. It can't print a singular atom. But what it can print is it can print, 0.035 millimeters or something like that. A ridiculously small size compared to a human, but a fairly large size when it comes to this caliber of part. So what we need to do is we need to make sure that it is larger than 0.5 inches. That way it can fit over a hexagon that is 0.5 inches. Because if any thermal expansion occurs or if it gets warped while it's printing, it won't be able to slide on as easily as we hope. And we want it to be universal. We shouldn't have to drill it out in order to use it. So we can double click on our dimension and it will reopen the menu where you can change the dimension. So instead of saying 1/2 inch, we're going to say the equivalent, 0.5. Except we're going to add 0.01. If I make it 0.51, enter, it makes it just a little bit bigger. This should, in theory, cover how big the printer settings are when it comes to the X and Y tolerances. So when we're making a 1/2 inch hex, we'll try 0.51 and print this off and see if it works. I believe this was 0.505 and it is a tad too snug and we'll need sanding. So if we do 5.1, that should be okay. Now we can deselect the dimension tool because we're not going to need it until we place a new object. Everything is a black line, which means that everything is dimensioned properly. If there's a blue line, that means that it isn't quite dimensioned properly. If it's a red line, it means that it's over-dimensioned, and if it's a gray line, it means that it is a driven dimension, aka you've put the same label on twice and accidentally created a duplicate. Is everyone with me so far?
I'm sorry. It's just the lines are of that shape is in blue, so I think I made something wrong, or I'm not sure.
Okay, I don't think you did anything wrong if it's in blue. What lines are in blue?
The ones from I forgot the name. The outer lines.
The outer lines, so the straight lines that form the normal hexagon.
Yes.
Okay. Did you dimension the circle?
I think so. Yes.
Okay. Are there any straight lines that are black?
Straight lines? No, just a circle.
Just the circle is black. Okay, that's kind of peculiar. When I define it, it automatically does it. Have you tried deleting the label and redoing the label?
I'll try.
Or refreshing the browser? All right, so while we're waiting on Giselle to do that, the next step would be to use the circle tool, specifically the circle tool that looks like a normal circle with a dot at the center and a dot at the perimeter. And we will be using that starting with the origin and then clicking somewhere outside of the hexagon. So I'll do that slowly while Giselle's doing her work. Martin, how are things going? Have you created an account?
Yeah.
Awesome.
I just don't know how to create an object.
So you have the 3 dimensions open. It looks
Yes.
kind of like this.
Yeah.
Okay. Click on the top view, and that'll get you to here. And then there should be a button over here that says sketch. My menu looks different because I'm making a sketch right now. But you have to create a new sketch, and then it'll be something to the words of select sketch frame of reference or select sketch plane. When it shows that on the screen, you have to click top. I guess you don't have to. It's recommended you click top.
Just show constraints and or disable imprinting or show over-defined like this. I can choose this 3 option.
That's a bit odd. Is it treating you like it's a tutorial? Is it guiding you through what the menu options do?
Maybe I don't know. I just click sketch and like the sketch one popping out and it said sketch plane.
Okay.
I'm
Sketch
not
plane, you then click top.
Oh, where can I click top?
So do you see where I'm hovering my cursor?
Yeah.
Pretty much there. So anywhere in and around here that doesn't touch one of these vertical or horizontal lines. And it should highlight this box in orange as you do that. Is it doing that for you?
So I just like after I click sketch and then I click the top. I'm not sure.
Yep, sketch, and then it says create new plane or select sketch plane or something like that. You select the top, and then it should show up with a menu of options.
I can't see select sketch plane.
Okay.
Yeah.
How about I stop sharing and you start sharing? I'll stop sharing mine, and then you share your screen, and then I can help guide you through yours.
Okay.
And for those of you who are not Martin, here's stuff that you can make if you get good enough at CAD. This is the head of a turret that was donated to my robotics team from Team 3161 Tronic Titans in Oakville, Ontario. This was created in 3 separate parts and bolted together using this sort of boltable design with like hexagons embedded into it next to the holes, so you can just set a nut in and then screw it in. And this fits a Falcon motor or a Neo motor, as well as a turret wheel, usually a billet or flywheel. It's pretty cool. It ended up breaking a competition, but it's really interesting. Anyways, Martin,
you need to give me access to.
I need to give you access. I don't remember. Multiple participants can share simultaneously. Okay, that should allow you to do yours. Okay, so you've got yours. Awesome.
I click this.
Okay, no, you should be hovering over the where it says top in the blue. Oh, you've created 2 sketches. So hit the red X on sketch 2. And then right click sketch 1, and then you want to delete all your sketches. Just start off from 0. You hit extrude and sweep and sketch. You don't need any of those. So I need you to right click each one and delete it. And we'll delete sketch 1 and then nope.
Yeah.
Oh, okay. It's looks like it's working, but you're going to want to delete sketch 1 anyways. And then sketch. And then hover over the blue box where it says top. Yep.
Oh.
Hey, there we go. So now you have selected top as sketch 1. And now you can start with the hexagon. You don't need to show constraints. You can leave it as is. Don't click that. So now you want to right click sketch 1 and you want to hit edit. No, you're already editing it now. Do not interact with that menu that is popped up there. That stays there until you're done sketch 1, and then and then you extrude sketch 1. You never actually exit out of that in the tutorial. So click top in the top right sort of cube that shows up in 3 dimensions. To the right, to the right, to the right. Move your cursor to the right. Yep, there you go. You want to click one of those. Click top. Yeah, there we go. So now that makes it so that you can see top head on squarely. And you're going to want to click inscribed polygon, which is the pentagon with the circle in it tool along the top tab.
Sorry, where's?
So you know where it says untitled document near the top left?
Yeah.
Underneath that and 6 tools in from the left. Okay, not including that one. No, keep going to the right, to the right, to the right. Yeah, there. Whoa, you've gone too far now. Inscribed polygon. There we go. Yeah, that one. Click that. And now click the center point on your drawing. Yeah. Oh, you didn't click polygon properly. There we go. Click. And now drag your shape out without holding it. Yep, that's good. You can shift it anywhere you want. Doesn't really matter.
Okay.
Oh, okay. You gotta move that around until it says 6, and then you're gonna left click when it says 6. Yep, that's good. Okay, and now you want to start with the dimension tool. So type D into your keypad. Don't click anything, just type D. There we go. So D turns on or off the dimension tool. So that's a hotkey. And now you click the circle with the dotted line. Yeah. And now you can move your cursor around and it will move the label. I like to have my label outside of the circle. Yeah, so anywhere near there. And now you can edit that by typing in your keyboard. You don't need to click right now. It's already selected. So type in 0.51. Okay, maybe backspace all of that and then type in 0.51. Okay, cool. So now you have hexagon of the appropriate size. Now press D again. Okay, and now you want to press the circle tool. No, not the circle.
Circle.
Click anywhere but the circle on the picture right now. Yep. Okay, so that deselects it. Now select the circle tool from the toolbox at the top. Yep.
Yeah.
Yep, that one. So that one also has a hotkey. That one you can press the letter C on your keyboard and it will toggle that. So now you want to do the same thing you did with the hexagon, except you want to make it bigger than the hexagon. Same center point.
Oh.
Nope.
Oh.
Same center point. So now click anywhere and then escape.
Yeah.
Hit escape and then select the circle you just made. No, select the circle and then hit delete. Okay, you didn't select this. Select the perimeter of the circle. There we go. Now you can delete it. Now let's try it again. This is getting us familiar with all the hotkeys. Click this, yeah. And then move your cursor out. That's good. Anywhere in there. Because we're going to use the label tool again. So I'm going to get you to go one step further than me now and dimension the perimeter of the circle to be 0.62 inches. Yeah.
I forgot how
0.62 inches.
I did the
D.
D, yeah.
0.62 inches. Awesome. That's exactly what it should look like. So seeing as you've caught up to me and surpassed me, I'm going to switch back to my screen. So if I can get you to stop sharing, I'll start sharing my screen. And then together we're going to end up with this part.
Thank you.
Thank you. All right. Can everyone see that?
Yep.
Awesome. So like what Martin did, I'm going to select the dimension tool and dimension this, and it's going to be 0.62. And because I'm already in inches, it automatically does that. But ooh, that is a tight fit between that and that right there. I don't know if it's going to be able to print that small of a shape. So what we can do instead of this is we can build in little tabs when we extrude this. And I'll show you how. It's a separate drawing that you essentially use as an eraser. I'll explain it later, but just know that that isn't going to be permanent. We will be removing material from the vertices. But right now we're ready to try out a new tool. So we'll deselect dimension and we will try the extrude tool. So by clicking the cube with the cube in front of it, that opens up the extrude and it tries to use mathematics to understand what shape we're trying to make, given what we've drawn. So it's filled in between the outside and inside of the shape, and it's come up with this. Now I'm going to use the middle part of my mouse here, the scroll wheel, to move around the three-dimensional plane. If you're on a laptop, you will not be able to do this, but if you've done it correctly, it will look exactly the same as mine. So this is what it looks like. This is a temporary shape that it's come up with of, okay, here's what I think you're trying to make. And by clicking top and zooming in, and we double check that we have selected the proper stuff. If we click this again and say, no, it actually isn't that, we have the option to then select something else. But it did actually predict exactly what I wanted to make. I want to make a hex spacer. Only instead of making it 1 inch long, I'm going to be making it probably 0.5, let's say. We'll make it 0.5 for now. And to help with that tolerancing, we'll type in 0.51 because we want it to be slightly longer than ½ an inch. That way it fits around a ½ inch spacer or bushing. So we'll go with 0.51 for now. That might be subject to change later. So with 0.51, and it looks good to me here, we're going to click the check mark for extrude 1. And now it creates a three-dimensional object. Again, I'm going to pan around, and it looks something like that. Does everyone have something that looks like that?
Yes.
Yes.
All right, Astrid. Chak.
Yes.
Chak, I can see you're in here. Is Chak not here anymore? Sorry about that. Zoom's being a little weird right now. So now that we have extrude 1 done and sketch 1 done, we are going to be adding something onto the bottom. So I want you to, either using this map around here or using your mouse, scroll around until you can see the bottom and then select bottom on the world key here. So we can click this a bunch of times until we see the bottom, and then it says bottom here, and we click that. It automatically centers to the bottom frame of reference. So now we're looking up at our object, and we want to create something a little bit bigger than what we had before as a nice base. And this base is going to stop linear motion from happening when we are trying to use this item as a bearing. So to do that, we need to create a new sketch. And instead of selecting a sketch plane, what we can do is we can select the bottom face of this part. So what we want to do is we want to select the bottom component of this three-dimensional object and say, yes, this is what I want to build my shape off of. This needs to be attached to whatever I make beyond this. So we click that as our sketch plane. And now instead of highlighting the entire square, it only highlights inside the circle, which I think is kind of cool. So is everyone at this point?
Yes.
Awesome. Now that we are starting to sketch something new, we're going to do the exact same thing. Literally the exact same object, except we're going to change the size of the circle outside of the hexagon. But this is going to be a lot easier because when we go to make our new one, our old one still exists as the frame of reference, so we can just snap our hexagon to fit the other one, and it automatically just works. All those lines are black. It automatically assumes that it's now the same size and shape as the hexagon that came before it, which is perfect. That's exactly what we want. 0.51 inches. And we can verify that by clicking this circle here and looking at the bottom right hand of our screen. And the bottom right hand should say 0.51 inches. So I'm going to make a new circle now, and that circle starts from the midpoint, as does all the circles using this tool. And we're going to make it slightly bigger than the circle that came before it, because we're essentially making a top hat shape. We're making a top hat shape so that stuff doesn't shift around too much. I don't know if you can see the lip on this thing, but that is a close approximation, or the equivalent of this. Two different size circles, one on top of each other. So I'm going to click the dimension tool, and we're going to mention as 0.75. 0.75 is a large enough margin that it'll keep stuff in place, but a small enough margin that it doesn't take up too much filament. So this looks about right. Is everyone at this point before we extrude again? Does everyone's screen look like mine?
Yes.
Okay. Giselle's good. Martin?
Typing the 0.75.
Excellent. Astrid?
Ready.
Awesome. So I'm going to deselect my dimension tool. We're going to go over and we're going to do the box on top of the box, the extrude tool. And now it tries to do math to understand what shape we're doing. And again, it gets it right first try. Sometimes it'll suggest something that's wrong, which is why I'm happy that it's doing the right thing right now. Basically, this software is smart enough to tell when a shape is closed, but not smart enough to understand the artist's intuition. This is kind of like art, only I don't have to worry about how steady my hand is. So this shape it's trying to extrude is way too thick to just be a brim. All we want to do is make a very thin layer that's physically larger than the other layers, so that it doesn't shift along the hex shaft. It only allows for rotation around the hex shaft. And to do that, we don't need 1 inch of filament here. We'll go with maybe 1/16. And if you're in inches, you don't even need to type in IN. It automatically understands what 1/16 is. If you're in centimeters, this works out to be about 1.75 millimeters. So that looks good to me. I'm going to click yes. And now we have this cool looking part. So this part should, I say should with loose quotations because this is version 1, it should be printable and just work. But we don't want it to just work. We want it to be even better. And the best way to do that is if we add another one of these on the opposite side. So that's exactly what we're going to do. Did everyone's brim turn out like mine?
Yes.
Yes.
Cool. All right, we got 2 yeses. I'm going to go ahead and look back at the top of my part. Now you can see there's 2 circles because one is below the other. It is the exact same as if you're looking at a top hat from above. Now we're going to create a new sketch. And again, we're going to make it on the end of this piece. And again, it highlights everything on the inside of the circle. This time it's called sketch 3. But sketch 3 is going to be a little bit different. We're going to start it off the same, but it will end differently because of sketch 4. So I'm going to draw sketch 3 exactly like how I drew sketch 2. And we're going to do exactly the same dimensions, except we have to define the circle because the outer circle is too far away. It's like we're trying to draw on something that is like this. And if I were to try and draw near the edge of this piece of paper, the piece of paper would not be able to be drawn on because it would just flex out of the way. So if you imagine it like a piece of paper when you're sketching, it just mentally helps with how to sketch things and why things don't automatically work. So this part here, we're going to set as 0.75 again. And there we go. It now looks like it's in line, but if I were to scroll around, it's hovering in midair. Cool. Click on top view again. And this time we're going to extrude exactly the same. 1/16. Maybe we'll go, yeah, we'll go 1 millimeter. And if you're in inches, you're going to have to type in mm. If you are in millimeters or centimeters, you should just be able to type in 1 or 0.1 respectively. So that makes a really, really thin version of this. It's about half as thin as the other one. And then we click yes. We want to make that into a three-dimensional part. So now we have this sort of spool or thimble looking device. And I just realized that the diameter is a little bit too big. So we're going to re-edit something. I'm going to show you guys how to edit a sketch. Right-clicking on sketch number 3, a whole menu pops up here. And we're going to look at the second highest option, edit. By clicking edit, it then allows us to go in and act like we're making it for the first time. And I'm going to change the dimension from 0.75 to 0.51. Sorry, 0.51 is the wrong size. 0.63. So that's slightly larger than the inner circle, but way smaller than the outer circle. So 0.63 inches. That looks a lot better. So it's just ever so slightly bigger than the thing we're making. So over here, that's 0.62, this is 0.63. And the idea is that we will then be able to sort of click things together like Lego pieces by using Extrude 4. Now, Extrude 4 is totally different, and I've not tried this in quite some time, so apologies if we don't get it right on the first try. But we're going to make something really complicated. Going into Sketch 4, we want to select the top plane again, which is the top of Sketch 3, and it highlights this again. Only this time we're going to use the line tool, or the L tool. By pressing L, you can toggle it on and off. We're going to have the first point of our line be here. We're going to go straight up and through one of the vertices. If your vertex is not in line with one of the cardinal directions here, that's okay. Just draw the line from the center to the vertex of the hexagon. This is going to act like your mirror line. A mirror line is when you're flipping something over, what's the center point between the two shapes? Is everyone with me so far?
Yes.
Right.
I think I missed out the sketch 3.
Sketch 3, okay, it's the exact same as Sketch 2, except it's on the top of the part instead of the bottom of the part.
And how's the number different?
The only thing that's different, the hexagons are the same. The only thing that is different is going to be the diameter of the outer circle. Rather than 0.75 inches, it is 0.63 inches.
Okay.
Is that okay?
Okay.
Awesome. Okay, so now that we have this vertical line here, Sketch 4, which is on top of Extrude 3, we are now going to add some more lines, doing the exact same thing. We're going to add one more line, except instead of lined up to the vertex, it's to the right of the vertex. You hit escape to exit out of that tool. And we need to define the dimension between these two. We're going to use the dimension tool in a way that we've never done before. We're going to click on one thing, and then we're going to click on another thing, and it will automatically assume we're trying to measure the angle, which is exactly what we want. We're going to measure the angle in between. So by clicking the more vertical line, and then rather than clicking where the label goes, you hover over the other line until it turns orange, and click that. Now we have a brand new, sorry, let me zoom out. We have a brand new label here. So 12.3 degrees it looks like. And I'll just put the label way over here, 12.300000062. That's a weird number. We don't need that number to be that weird. I'm going to change it to 10, or maybe we'll go with 6.25. We'll go with 6.25 degrees. That way, when we do the other side, it'll come out to 12.5 degrees. Does everyone have this so far?
Can we go back a little bit? I didn't get it.
Okay, we can go back a little bit. Everything with Sketch 4 or just back to the vertical line on Sketch 4?
The vertical line.
The vertical line on Sketch 4. Okay, so I will just delete the other line. So this is what your screen looks like?
I think one step before.
One step before that?
Yeah.
So that?
Yes.
Okay, so we're going to start with the line tool over here. And our first point is going to be the midpoint, just like we're drawing a circle, except now we're drawing a line. We're going to line that line up with the vertex of this hexagon. And then we're going to extend it beyond that, outside the shape. And then we can click it. And I'm going to deselect the line tool. Do you have that?
Yes.
Cool. We're going to do the same thing, except instead of lining it up with the vertex, it's going to be skewed off. So they meet at the center, but it's like a pizza slice. Like that. Do you have that now?
Yes.
Great. So now that we have this, we're going to use the dimension tool. We're going to select one line, and then before we place where the label goes, we select the other line in addition to the first line. This makes the computer realize that you're trying to define the space in between. But since they meet at a point, it now understands that you're looking for the degrees. So you click and drag the label out here, and it shows up like this. Is everyone following?
Yes.
Okay, Martin and Astrid, you're here as well?
Yes.
Yeah.
Excellent. We're going to modify this dimension to be 6.25. And it automatically understands that we're in degrees. We are not in radians or gradients. And it should look like this. Now I'm going to deselect the dimension tool because we're going to use another new tool. And that new tool is called mirror. To mirror something, you first have to select the tool, and then you have to define where the mirror line is, and then you flip whatever you want across the mirror line. To do this, we are going to be selecting the mirror tool from here, which looks like this. So select this tool, like that, and it says select a mirror line. Well, the mirror line that we want to do is the line that's oriented to meet up with the vertex of the hexagon. So in my case, it's the vertical line. In your case, it's whatever one touches the edge of the hexagon, the points of the hexagon. So now that I've selected it, it now highlights it in light yellow to indicate that that is the mirror line. Now it says, select what you want to mirror. Actually says select entities to be mirrored. However, you can interpret it that however you want as what do you want to flip over this line? So we go, well, I'd like to flip over this other line, which I'm highlighting in orange. And we click that and it goes, okay, I flipped it. Now what? We go, well, that's it. We're going to deselect you. Is everyone at this point?
Yes.
Awesome. Martin and Astrid?
Yeah.
Okay.
Yeah.
All right. So now what we're going to do is we are going to draw our big circle again and draw our hexagon. But now we've got this little piece here to annoy us a little bit. So I'm going to start now with the inscribed polygon, do the exact same thing that we did before. But now we're going to line it up like that. And by now we should be pretty good at creating circles. We're going to make a circle and we have to define the circle, but we don't have to define the hexagon. This one is going to be, sure, we'll make it 0.75 because it doesn't matter how big this circle is as long as it's bigger than the last circle we made, which is 0.63 inches. Because again, we're building a negative part right now, which sounds weird. But sketch 4 is a negative part that we will negatively extrude to remove parts of sketches 1 and 3. And I'll explain that when we get to the extrude function, because that sounds a lot more confusing than it actually is. This is a pretty straightforward thing. So before we get to all that confusing stuff, we have our part. We're going to use the trim command. The trim command is a pair of scissors. You can toggle this by clicking M on your keyboard if you prefer to use keyboard commands. So when we click the scissors and we hover over a part, it shows us a line segment or a circle segment. We want to click on the line segments that are outside of this circle. And by clicking it, it deletes that line segment. So we can go in and we can clip it off just like we're cutting a sheet of paper with scissors. And then you deselect the tool. Is everyone at this point now?
Yes.
Cool. Martin?
Yes.
And Astrid, I'm assuming you are also good with this? All right. As soon as you guys are behind, please let me know from here on out because we're going to go a little bit faster. We're going to click on the 2 points that are left over, and we're just going to delete them because we don't need those points. And that deletes data that doesn't need to be rendered anymore. If you know you're never going to need a point again, it's important to get rid of it. That way it doesn't skew what you remember about this part or what you're trying to make. Now we're going to use a new tool on this center point here, and that's the construction line tool. So you don't even need to select this tool for it to work. You can just press the letter Q, and it automatically uses the tool on whatever you've just selected. And this tool allows you to change a line to a construction line and back again. Basically, a real line to a fake line and back again. A construction line is a fake line that instead of creating a part like this, you could draw on this part. And you can measure the drawings on this part, but it doesn't impact the overall shape or weight or center of gravity. It's just a drawing on top of a part. So that's what we use construction lines for, and that's why we need one on the inside of a hexagon. So all the dotted lines do not count when it comes to creating a 3D part. And this is all done to help not confuse us. Now that we're done that, we are going to click a new tool, and in order to click this tool, we have to scroll down a list. So we have to click the drop-down menu next to this 4-box tool. The 4-box tool is next to the mirror tool, and it is usually called linear pattern. We're going to click on the drop-down here and select circular pattern. Now that we have the circular pattern, we can select the points that we wish to orbit around the center point. And since we built the entire part from the ground up on the center point, anything we click will be rotated around the center of gravity, which is super important. When you're building anything circular, make sure that the center point is on the origin. It makes your life so much easier. So you should just be able to click these two, and it will show up with phantom lines or fake blue lines to indicate 3 sections of rotations. And there's this new label here that says 3x. The center is correct, but the number of times we want to rotate it is not. We want to do it 6 times. So it interacts with every vertex on that hexagon. So we can double click this, press 6, and then press enter. And it should look like this. Now before I click the left mouse button, is everyone okay with this? Are we all on board?
Yes.
Astrid and Martin, I'm assuming by your silence that you are okay. Awesome. So we left click, and now it looks kind of like a snowflake, kind of like an explosion, whatever, what have you, a crystal. All kinds of cool art can be made using this software. But we're not focused on art right now. What we're focused on is reverse extruding. So to reverse extrude, we act like we're going to create a new part by doing the box on top of a box extrude tool. But now we want to delete the faces that we've selected and switch tabs from adding a solid to removing a solid. Now we can scroll in 3 dimensions to view what we actually want to select as removable. And I'm going to select this piece here, this piece here, this piece here, this piece here, that region there, and that region there. And now it's telling us, okay, you want to remove 1 inch of material in that direction. That takes you all the way to the bottom. Are you sure you want to do that? And we're like, well, we don't really need it to go all the way to the bottom. We just need to go it kind of to the bottom. So instead of going all the way to the bottom, we need to figure out the distance between here and the bottom. Or sorry, the top of the bottom. So extrude 2, we want to keep intact, but the other 2 we want to remove material from in this pattern. Before I continue on with the depth of negative extruding, does this make sense to everyone? Does everyone conceptually understand what we're doing here?
I don't know why I can't select the remove part.
So there's sections over here on the extrude. Do you see where I'm pointing with my cursor? You can't click remove.
No. The part that we should remove.
Oh, you can't click like here or here. Huh. Maybe it's because the lines don't interact properly. Like it needs to be a closed shape for you to click it. It can't be a fake line. So the center fake line here cannot be selected. As I'm trying to hover over it, it only selects the orange lines. And this fake line here is not one of those.
Yeah, maybe it's fake.
So maybe try redoing extrude 4 or redoing parts of sketch 4.
Okay.
I think it might be the same issue that you ran into last time, that you've now clicked too many things and it's trying to do too many things at once. So I'm going to keep moving forward, and at the end we can go back and troubleshoot your system, Martin. Okay. So to determine the distance from the top of the part to the top of extrude 2, we are going to be using two different units of measurement, because if you remember, extrude 3 was in millimeters and extrude 1 was in inches. We extruded 0.51 inch and 1 millimeter. So we're going to change this to 1 mm plus 0.51 in. Enter. And it automatically does the conversions and understands what distance that is. So 1 millimeter plus 0.51 inches is the exact distance we need. We don't need to interpret that at all. We make it do the math. And then we scroll around. Yeah, that looks pretty good, actually. That lines up exactly. We're going to extrude in that direction. And then, whoa, we just made a really complicated part. That looks awesome. Is everyone at this point? Giselle and Astrid.
Yes.
Awesome. Okay, so we've got this part, and it's looking real good. It's looking real shiny. What we're going to do now requires me to move the viewport for all of you guys. So I'm going to put you up near the top of the screen. Maybe, no, I'll put you on the left-hand side of the screen. And what we want to do now is we want to click on one part of the three-dimensional part. It doesn't matter what part. And then right-click. And if you'll notice, it says assign material for part 1 near the bottom. We're going to assign a material for it. By clicking assign material, it shows up with the OnShape material library. This library, if you click on none, it shows up with like a billion different options. Billion is maybe a strong word. A bajillion shows up with a bajillion options for all kinds of cool, notable ingredients when you're making stuff. So you can make stuff out of zinc, wrought iron, tin, Brazilian rosewood, neoprene, iridium, and so on and so forth. Most of the ones I've listed are really weird compounds that in robotics we never use. But it's nice that you can then assign a material for this, and then it will tell you the center of gravity, the mass, and the density, all of which are extremely important when it comes to designing aerospace parts or robotics application parts, because the lighter the part is and the stronger the part is, the better. There's even one for brick. You can make something out of bricks. So this one, we're 3D printing, right? So we need something that is representative of the plastic that we use. So if I type in plastic, it shows up with everything that is defined as a plastic. We've got ABS, Delrin, acrylic, HDPE. As somebody who's worked in industry, I know that all of these are different and they have different strengths and weaknesses to them. We're looking for something that is called PLA. So if I only type in PLA, it highlights PLA right here. We're going to click PLA and assign the material as PLA, which is polyuronic acid, a very specific kind of plastic. The density is 0.045 pounds per cubic inch. So if I were to make a cube 1 inch in dimension, it would be 0.045 pounds. Tensile strength is under 10,000 psi. Tensile yield strength, Young's modulus, these are all very important things for university level classes. We are not doing that. So we'll just say, yes, this looks right, and we'll assign the material. So now, now if we deselect everything, we should be able to press the display mass properties tab in the lower right corner, which looks like a weighing scale, like one of those really old devices to determine how heavy things are. So you want to click that, and then you want to click the part, somewhere on the part. And it automatically selects the entire part. And it shows up with this cool little crosshair in the middle. And this cool little crosshair is actually the center of gravity, center of mass for this part. So we know where it is when it's balanced. We could balance it on the tip of our finger if only we could hold it exactly in the middle of the part. That's pretty cool. What else is cool? It shows us exactly how many pounds this part will weigh once we've put it together. Now, this is important for FIRST Robotics because the entire robot has to weigh about 68 kilograms or 125 pounds. If we're over that, we have to remove components or drill holes in the components until it fits under the weight specifications. So we want to design things that are light but strong at the same time. And this tool allows us to double check the weights of every custom part we make and compare it with adding up all the parts we already physically own, like this motor here, to determine how close we are already to the 125 pound limit. I'm going to exit out of that, but it's a neat thing to play around with. Select this one here. That's what we started with at the beginning of the day. So this is our part. I think it looks rather cool. Would anyone like to suggest a color that we will recolor this part?
Purple.
Or purple. Yes, purple.
Purple, or what was the other one?
Red.
Red. Okay. Well, we're going to recolor it purple, but keep in mind that the current spool on the Ultimaker, which is running right now, is like a metallic silver. So if we were to print it tomorrow, it would be metallic silver. It doesn't matter what we assign it now, but it's kind of cool that we can change the color, and I'll show you how. So you want to click a part, and then you click Appearance Panel. And then all of part 1 is here. You double click to edit, and you can click on any color you want here. Or you can type in custom color combos. So I specifically looked up the exact color code in hexadecimal for Columbia International College, which is our robotics team's host school. And our school color can be CADed. So we can now CAD parts in CIC maroon, and it is perfect. So this is the exact part color that we went for. Last time we made a bunch of parts, but we are going to choose purple because Astrid said we should. So this part is now a purple part, and we can click on the appearance panel again to close it. And we have our own purple 3D printed part. Now, Martin, I understand that you were having some issues about 10 minutes ago. Are you still having those issues?
Yeah, I think I mess more things up.
Okay, so for
did.
everyone else, I think we're done this part for today because it's a really good looking part. I actually can't wait to print this next week. But we're going to go back and we're going to make sure Martin knows how to make this part as well. So for people who are watching this on YouTube, presumably in the weeks to come, this is where you would end the tutorial. But if your students are having trouble, or if you are a student and you're having some troubles, come watch as we try to debunk what Martin is going through right now. So I'm going to stop sharing my screen, and Martin, you're going to take over and show me what you have. Some kind of technical noise.
Yeah, I think it's quite different actually.
Okay. So share your screen when you're ready. Okay.
I did many things. Like I think I need
so
to.
You've got extrude 3, but you're that sketch 3 you've got.
That's actually not the.
Oh.
No.
Okay.
Yeah, I need to delete it. Right.
So sketch 3 was supposed to be the same as sketch 2, but on the opposite side of the part. Did you do that?
I think I can't do the opposite side because, like, I just do it the same way and it will be the same position.
Okay, so tab over to add. No, inside extrude 3, tab over to where it says add instead of remove material.
Yeah.
Scroll around. Okay, so you're trying to create a part in that direction. So you've made the mistake of skipping ahead, which is not a bad thing. It just means that you're a little confused. Can I get you to delete sketch 3 and extrude 3? No. You're about to delete 4 things at once. So click the green check mark on extrude 3, and now delete extrude 3 and sketch 3. Awesome. Okay, so now I want you to select the small end of the hex part you already have as the. So instead of that end that you made that extrude and sketch 3, use the opposite end of the tube. You're sketching over here. I want you to sketch over here. Same exact thing, just opposite side.
Like this.
Yeah, scroll in until you can touch the actual face of it, not just the edge. But yes.
So.
How about you deselect everything?
Is the hexagon or just the circle?
Just deselect everything. You're still selecting one thing. Deselect that. Okay. Now view the bottom. Click the bottom so that you can. Okay, other side. View the top.
Top. Here.
Yeah. Click to snap to the top. Okay, and zoom in. Great. So now click sketch. And select in between the hexagon and the small circle. Hover somewhere in there. Yeah, click somewhere in there. Okay, now I want you to create the exact same thing you did for sketch 2.
Because I tap the top. I know what's wrong.
Okay.
Yeah.
So I'm gonna let you figure that stuff out. And you can keep sharing your screen if you want. If you don't want to, that's okay too. So Giselle and Astrid, what did you think of that lesson on OnShape?
Well, it was pretty cool because like the thing looks very complicated to make, but it's actually like more simple than I thought it would be. So great.
Yeah, removing pieces makes it look really, really complicated, but it is pretty straightforward to make. Especially when you're making something super custom like this, where it almost doesn't matter what dimensions you use for things like the width of what we were removing. Like it doesn't matter how wide that is, as long as there's 6 grippers that grip the hexagon properly. And I think this will work out well because I was running into issues with this one in particular. I don't know if you can see the layer lines, but this is so small that it kind of only prints like one section near the points. So I'm thinking, okay, what if we build something on both ends and then we can remove the points? And it should make it decently strong.
I forgot the what should I do next? Like what?
Okay, so you want to dimension the circle.
Yes.
And you don't want to dimension the circle to be 0.63 inches. 0.63 inches. Yep. So it should be just slightly bigger than the other one. Yeah, that's great. Now I want you to extrude it again. Click extrude, and instead of making it 1 inch, we're going to make it 1 millimeter. So you type in 1 mm. There you go, enter. And that's good. click OK, or the, yeah.
Okay.
Now you have 3 of the 4 extrudes. The 4th one, we're going to be removing stuff, but I want you to click a new sketch, do the exact same thing as sketch 3.
Do the exact.
Do the exact same thing as sketch 3.
So I click
Yep.
here. And yeah.
Mm-hmm.
How about the circle should
Yep.
be
Yep. Make the circle as big or bigger than the circle from extrude 3. It almost doesn't matter how big you make that circle. Okay, and now deselect the circle tool and select the line tool. Now you want to start a line in the center and you want to draw it up and outside of the circle. Okay, you didn't, yeah, up and outside the circle. It doesn't matter how long it is, just up and outside. And then click the second point. And now I want you to do the same thing, but now you're going to make it a pizza slice.
Oh, like this.
Yeah, like that. And again, it doesn't matter where, as long as it's outside of the part. Cool, yeah.
And
no, you don't need to do it again. Now I want you to dimension between the two. So you want to click one and then click the other and then move where the label's going to be.
click one.
So deselect the line tool. Now hit D. And now I want you to click both lines and then create a dimension for the 2 of them. Yeah. Only you want it to show the little sliver. It's, yeah, like that. And that's going to be 6.25. We're just trying a number that works out to be 12.5 when it's multiplied by 2. 12.5 should be okay. So yeah, sure, that works. Now I want you to use the snip tool, the trimmers, the scissors. Yeah. And I want you, nope, don't click in there. Click outside of the circle on those 2 lines.
Both nine.
Yeah, delete both the lines outside of that circle. Because you want the angle to be correct. And now escape. And now select the 2 little dots at the top that you just made. When you scroll out, no, keep scrolling out. You've created 2 dots there. Delete them. Great. Now you can scroll back in, and now you have 2 lines there. You're going to use the mirror tool, which looks like this.
Okay.
And now you want to select the vertical line. Yeah, I guess that works. And now you want to select the line that's like this. No, you can't select that. That's a dimension line. You have to select the line inside the circle now. Yeah. And now it mirrors it on the opposite side. You see how that works?
Yes.
And now you can hit escape, which exits you out of that tool. So now that you have that tool down, there's another tool I want you to learn, and that is the circle, the like bolt circle tool. I don't remember what it's called. Yeah, circular pattern, that one. So click circular pattern, and I want you to click on both of those lines, this one and this one. And click on the other one. And now I want you to click on where it says 3x. Double click the 3x label and change it to say 6. Enter. Great. Exit out of that tool. You have just created 6 of those shapes. Oh, sorry. You have to redo that. Instead of exiting, you had to hit enter. My apologies. That's on me. Great. Enter.
I think I press.
It's not hitting enter. That's okay. It's browser based. It's probably the internet.
Sure. Ah,
Ah,
do again.
yeah, do it again. But this time go slowly and don't select a ton of things. You've selected the circle. Deselect the circle. There we go. Okay. Change to 6. Enter.
Enter.
Looks good to me. Enter.
Enter.
Okay, left click maybe? Yeah, left. Don't select anything. Just hold it outside and left click.
Oh.
Okay, so left click was the correct function. Left click and enter for me are the same tool. I guess for you it's two different things. So now that we've got that, we are going to extrude again. So go over to the extrude command. And you're going to extrude, except now you're going to change to remove material.
Yeah.
And go back to where it says remove material. Whoa, stop clicking stuff. Stop clicking stuff. Go over and delete all of the things you just selected. All of them. Delete them all.
Wow.
I don't know how you managed to select like 18 things all at once, but we only need to select like 6.
Yeah.
So I want you to go in and only select the things that you need to select. Yep,
Here.
that one and that one. Those 2. And now I want you to do that on, I guess you'll select 12 things. Select all 12 of them as you go around. Yep, that one and that one and that one. Cool. So now you've selected those things and you want to remove material, but you don't want to remove an inch. So now instead of typing in a depth of an inch, you want to type in 1 millimeter plus 0.51 inch.
Plus
0.51 IN.
Sorry, it's 5-1, right?
Yes. IN. Yep. And then hit enter. And it automatically did the math for you. So if you change how you're looking at it, scroll around. Oh, you made your part extra long. Okay. We can fix this now, but that is the correct depth for extrude 4. So click yes on check the green check mark for extrude 4. And now I want you to go back into extrude 1. Edit extrude 1. And you typed in an inch. You need 0.51 inch. 0.51. There we go. And now click yes. Great. Look at that. You have, why is that different than I was hoping? Can I see the bottom of your part? Yeah, okay, that's kind of weird. On mine, it's still a hexagon at the very bottom. On yours, it should be a hexagon on the very bottom. So I don't know what the difference is. Oh, and zoom in. Look at that. That's kind of weird.
Yeah.
I'm not really sure what happened there.
I just like typed some inches wrong and
no, you didn't type in anything wrong. It assumed that you had clicked something that you hadn't. So when you removed the material, you didn't remove enough material. So I want you to edit extrude 4. Okay, now zoom in. Zoom in, 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 zoom in. Keep zooming in. Whoa. Okay, you want to see one of the edges of the hexagon. Zoom in to the edge or vertex of the hexagon.
this.
Keep zooming in. Keep zooming in. Keep zooming in. Okay, there we go. So now I want you to click the 2 little tiny lines that line up with, that zone right there. And then
What?
and then mirroring it. Yeah.
Is this right?
And then, oh, you deselected another one. So reselect the left one. Yeah. Okay. Now I want you to do that on all vertexes, and that should fix your issue.
So how can I mirror it?
You can't mirror that. You have to go in, zoom out, zoom in, zoom out, zoom in, zoom out, zoom in, and click those two things individually. I'm not sure why they haven't lined up, but it doesn't matter now.
Okay. There's just one
Yeah.
part.
Okay. Do the hexagons on both sections of your part line up? I think they do.
Yeah. Yeah, I think.
Oh, it doesn't look like they do anymore. I'm a little confused. You know what? That should be just fine. That should be just fine. So right now you've got 0.549 inches. That is the correct amount, right? 1 millimeter is 0.039 inches. Then why is it's deleting stuff all the way down to the opposite side of the face, which isn't terrible. It's not the end of the world. It's just weird. So click yes on extrude 4. Okay. So I guess your part will have those weird rectangular grooves out at the bottom. And that's okay. I mean, it doesn't change how it gets used. In fact, it might actually be beneficial because it removes excess material. So now what you want to do is right click on your part, anywhere on your part. And at the bottom, it says add appearance, but above it, it says assign material. At the bottom of that list, go up, assign material for part 1. Below, below, below. Yep, that one.
Oh.
And now click none. And now type in PLA. STIC, I guess. Plastic.
I guess.
And then scroll down until you see an option that says PLA. And I want you to click that. Okay, PLA. Whoa. There you go. And click the check mark. And now deselect the part. The lower right-hand part of your screen, the very bottom right corner, there is a weighing scale icon next to a tape measure icon. Click the weighing scale and then click the part.
Sorry.
Click the part now that you've opened mass properties.
Oh, yeah.
Click the part. No, don't click anything on the menu. Click the part. Click the part.
Like the part.
Martin, click the part in the picture of the thing you just made. Okay, perfect. Hey, okay. Now, how heavy is it going to be when we print it?
Yeah. 0.002 pound.
Excellent. 0.002 pounds sounds correct. Now, if you zoom out while mass properties is open, you should see a targeting crosshair.
Like,
zoom out while mass properties is open. So keep zooming out. There you go. Do you see the target?
Yes.
That is your center of mass. So can you then scroll around in 3 dimensions? And you should be able to see it better. Yeah, there you go. So it's somewhere in the inside of the part, and it is centered along the axis of rotation. That's perfect. That's exactly what we want. If the center of mass was off by a bit, we would know that we had made it wrong, because then the density of one side is heavier than the density of the other. But this one's perfect. We can put it on a rotating shaft, and it's not going to make the shaft want to jump around. So that's great. I think you're all done aside from changing the color. So I need you to exit out of mass properties now. And you should be able to open a tab on the right-hand side of your screen that looks like 3 circles. One is blue, one is gray, one is white. Tab on the right-hand side of the screen. Yes, click Appearance Panel, double-click Part 1. And now you can pick any color you want.
Beyond.
Okay. Dark red, cool. And then you click yes on the appearance. Great. And now you can click the appearance panel to make it minimize again. So if you click on the thing with the 3 circles, no, not that thing with the 3 circles. The thing you clicked on to open that window closes that window. Great. You have just completed this part.
Yay.
Great job, Martin. Great job, Giselle. Great job, Astrid. We are slightly over time. However, all 3 of you have successfully created a part that can be 3D printed tomorrow if we wanted. Unfortunately, we can't because there's a test tomorrow. But we will start printing these on Monday and Tuesday. Excellent work. Now, I will be swapping over to Discord for a team leadership meeting. All of you are welcome to join. It's where we're going to be discussing some future ideas for the team. But I'm going to stop recording this now, and we're going to upload this to YouTube. So in the future, for those of you watching from the future, thank you very much for joining us. And if there's more of these, enjoy. If there isn't any more of them, stay tuned. We'll be making a second series soon.
Remember to subscribe and like.
Make sure to like and subscribe.
And share.
And share this with a friend. All right. Bye, everyone.